All right. Good evening, everyone. Thank you for coming to this SF AI Agent Memory Meetup. I'm Ellen. I'm from Mem0, and currently I'm working as a growth engineer. So today we're going to talk about how we built the token-efficient memory system for productions, the ones that we actually just launched last week. So this is actually the first time we share it in public. If you guys have any questions, I'm also bringing our AI researcher here, Mem0, and then he's here happy to answer any type of question when it comes to the algorithm. All right. To give you an idea, also currently I'm writing in context. In Mem0, we start this weekly Mem0 column on AI agent memory. So we write everything about memory and context engineering in open source project. Mem0 also, we have multiple products. One is the open source one. Currently we have 50,000 GitHub stars just last month. And then we have 100,000 developers in our hosted platform. This is one of the few articles I wrote at Mem0, so how memory works in cloud code, hyperagents, Beam memory benchmark, DFlow, Hermes agent, one of one new agent harness family. So yeah, we're very supportive with open source community, and if there's any specific topic you'd like me to write about, I'm very happy to talk to you after this event. So what is Mem0? Mem0 is a memory layer for AI agents. Currently, it's available open source and also self-hosted. You can either self-host it on your own, or you can just get the API key from our platform. Currently, we're trusted in productions. There are around 1 trillion API calls, actually. Now, since it's been 2 years, Mem0 has been around. We're one of the AWS Agent SDK memory provider. And as I mentioned, we have 50,000 GitHub stars with 100,000 to 150,000 pip installed daily. Now, I want to ask a question. Raise your hand if you have used AI memory system before. OK, I got 5, 10. All right, what memory system are you using? OK. Oh, that's interesting. All right. So when it comes to memory, I think this is actually related to how communication works. I like to think that the way human evolves is actually related to how human communicate. Back then, we used messenger to send information, and then there's a smoke signal, and then humans start to send data with pigeon. You know, we train pigeon to do that, and then there's phone, there's IM, and then after that there's text. And then I actually come with this conclusion that if humans could actually communicate more efficiently, we would actually be in a different world by now. And especially now with AI agents, this can actually be accelerated. This day I could just prompt to my computer, and then you'll actually create an app. When it comes to knowledge or context, we've actually tried to do it back then from different way, right? We used to use language as the way we share context, and then after that, we share context through writing around 3,000 before centuries, and then there's binary and digital storage, how we start storing information with 1 or 0, and then spreadsheet comes when we actually need to have structured human data. However, the data actually grows. We need relational database. After that, in 2017, now LLM has become actually a new product that we use daily. We have stored memory using weights within the models. However, the knowledge can get compressed into parameters, and then it could be expensive to update. Traditional, conventional memory system like relational database, data like is not enough to store this. We need a new memory system, hence we come up with this context system to be able to actually store and this memory without compacting this knowledge. So how does the memory extraction work in Mem0? I think this is the simple way. You can just write in your chat interface, the user weighs 72 kilogram, target 130 gram protein daily, and wants 20 pull-ups. This is probably just a simple message, but how do we actually store this, right? After that, we'll actually extract this memory into facts. It will probably take around 46 tokens, and tokens is the currency when it comes to AI memory. And later on in our system, we'll be able to know what's your diet, what's your preference, and then where is the source? Is it coming from user chat, or this is coming from agent? And then we also will be able to store the confidence. Now, how it works under the hood, it's actually multi-step that we share. This architecture, we also share it in our GitHub. This is open source. But I think I could highlight the first one that I shared earlier. So when you user chat, we actually store the new memories, and then we process this asynchronously. And then the second picture that I saw previously, we extract the memories from input and then context. I'll talk more about this in the next slide. And then lastly, this information is actually stored in our persistent storage. Now, there are many memory solutions out there. How do we actually measure the memory performance? So there are few memory benchmarks available out there. I'm gonna explain quickly what are these benchmark means. So there are MSC, Dulemon, Memory Bank, Locomo, Long Mem0, and then recently Beam. If you see on the top part, I'll zoom in after this, there's information extraction, multi-hop reasoning, knowledge updates. This is all different cases that these benchmarks are actually testing. And you can see how this has been developed from like multiple years. Locomo is like from 2014, and then Long Mem0 is a bit newer with longer memory 2025, and then we have Beam that is recently developed. And then this benchmark is actually updated by the researcher to be able to keep up with the speed of how AI agent and LLM evolve. So when it comes to information extraction, this is one of the example. One of the things that being tested is how we can actually extract facts and information. For example, I just have a connecting flight. I want to know how long is my transit time. In Long Mem0, this is actually stored as a single session user case. And then there's another example when the agent actually gives you an example. Can you remind me the flight that you recommend? So it means that the agent or the assistant is giving you a memory. So this is single session. There's also multi-session memories, how the agents are able to remember memories over different sessions. Another one that I think worth to know is the temporal reasoning. This is how the agent able to recognize changes over time. For example, I used to live in Saudi before moving to San Francisco. So when I talk to ChatGPT or like Claude, I'll say, hey, I just moved from Saudi to SF. Let me know what places I should visit. When I ask the agent maybe to fill out some form, I will ask the agent how many years it's been since I live in San Francisco. I need to know for like my tax filing, and then the agent will know you've been here for 2 years. So this is temporal reasoning, how the agent able to get the information and recognize information over time. There's also a knowledge update. I think this is very straightforward. The agents understand time relationship. For example, in March 2024, maybe I read about, I like to go to Al Nakhil. I used to live in Riyadh. And then in July 2024, I read about, I start my grad study in USF in San Francisco. So now the agent actually knows the memory now that I live in SF. It doesn't replace the fact that I used to live in Riyadh. That fact is true, but the current memory of my location is San Francisco. So that's sort of like a high level. Of course, there's like 10 different things that's being tested here. Now, how about like this part? What is this chat length? So within memory benchmark, again, this benchmark is developed over time. There's MSC with 1K, Locomo with like 10K, Long Mem0 with 115K token or 1 million token, and then recently Beam actually has various tokens. So what does it mean? I think before I start, I want to share that this day, with the speed of how AI agents grow, scaling context doesn't actually mean scaling intelligence. We used to think if we have a bigger model, does it actually mean we have a better memory? Does it mean we actually have better intelligence? I wouldn't agree 100%, hence this is why we need memory. This is a graph of how the model size grow over time, and specifically how context window grow over time on the right side. Every other month, there's always new model. Even recently, we got Opus, we got Cloud Meters. I don't include it here because I wrote it a month ago. And I'll focus on these slides right here. So you see how the context window has grown. Previously in 2020, GPT-3 4K, GPT-3 was like 4K tokens, and then we got Cloud 2, which is 100K tokens, and we got Gemini, 1 million token, Grok 2 million, there's also Llama 4, 10 million tokens. However, despite the models actually can have this long of a context window, the performance actually degrade. For example, Gemini 1 million, it stops working around like 500K or like 300K when it comes to the result. So despite we have context window, it doesn't necessarily mean we can actually store this much information. Now, what does it mean for the memory benchmark? Now, it means that if we actually try to build AI agent memory with a better model, when I'm testing my memory system on this framework, the 1K, 10K, I could actually sort of p-hacking this benchmark. If you guys come from the research background, there's a term of p-hacking, how we can actually sort of hack the result by changing the situation, right? So now I think what I want to highlight, there's a new benchmark here, which is BEAM. It's actually testing across different conditions, 1 million contexts, 10 million contexts, which means all the model that's actually new, we can actually really test the capability of the model. They're still new. I think it's around like 2-3 months. So there's not a lot of memory system that benchmark around it. But I think it's nice to know when it comes to memory system, with the fact that how AI LLM has grew, the benchmark actually should be able to keep up with this, so we know how good the actual memory system is. Now, we've seen how the memory benchmark actually what is being tested. What does it mean for production? As I mentioned, in Mem0, we are blessed that we have more than 100,000 developers, so we can see what actually the developer need in production. So what benchmark actually measure was the accuracy, right? But when it comes to production, there are other things such as the token costs. In order for us to reach that number, how many token that we have to spend in order to retrieve a memory. That's also important because that's going to be a cost. That's what your CXO measure and actually care, right? And then it's something that you'll care when it comes to scaling. Another thing is latency, which is very important for user experience. I could, of course, pass the whole information, but how long does it take to actually retrieve the information? So that's another thing that's important. Now, in Mem0 last week, we actually just released our new token efficient memory algorithm. And then what's changed in it, I'm so excited to explain about it. One is we have the single pass add-only extraction. I'm going to talk about this on the next slide. And then we have entity linking, multi-signal retrieval, keyword normalization, and another thing is agent-generated facts are now first class. What it means is previously, I think we give weight for the facts from the user, but the fact that now agents are actually actively interacting with us. Maybe you write one line of prompt, but the agent will generate 3 paragraphs of prompt. What's essentially store information as well. We actually now treated the agent-generated facts with similar weight that we give to the user. Now, what does it mean when it comes to when we say we have a single pass add-only extractions? So in our algorithm, we pass the new message, the user, and also assistant. We also pass the existing memories that we have from that given user and conversation summary. And then the output is actually self-contained factual sentences. And it's only add operations. Previously, we actually do add, delete, and update. But when it comes to memory, it will be very tricky and expensive if we just update the memory and then we actually give the weight of reasoning to the memory system. When it comes to memory, as I mentioned, I used to live in Riyadh, and now I live in San Francisco. I cannot just delete the memory that I used to live in Riyadh. Both of these memories are equally important. However, there are memories that has more weight when it comes to time, the fact that I live in San Francisco. So hence now we actually only do add operation. And then when it comes to tokens, this is actually saving the tokens as well, because we actually store this information. We also have a multi-signal retrieval. I think what you can focus on is like the one in the middle, which is this parallel 3-layer signal retrieval. We're doing semantic search, keyword search, entity search. I'm going to explain how do we actually be able to score this signal. So we have this formula, which is the semantic score between 0 to 1, and we have the BM25 score between 0 to 1, and an entity boost between 0 to 0.5. The entity, we're trying to extract the entity from the facts of the user, and then final score, we actually normalize it to 0 to 1 by dividing by 2.5. And then with that, we actually solve multiple elements from here. One is we solve under extraction or over compaction. Previously, if a user say, hey, I'm flying to Tokyo next week, and then the agent say, great, I book you on the 3 p.m. flight on March 15. Now, both query actually stored from the user and assistant. That way, we actually store the cause and then the source of the facts, right? So no memory loss, which is very important when it comes to achieving good performance. And then we also solve verb conjugations by adding lemmatization in our system. So this is in the platform, in the algorithm in the backend. Previously, when there's a sentence that says, what meetings did I attend? And then there's a text that say, I attended meetings. If we just use BM25, this would actually be treated as different tokens. So hence, adding lemmatization here is actually giving context. There are different lemmatizations out there, but as a simple example, runs, running, ran, as a human, you know, we understand that this actually means run, but like algorithm, they don't understand this. So we actually need to do like this simple NLP preparation, but it's actually help our algorithm a lot. And then lastly, it's also solved that now we actually have matching at different granularities. So for example, when there's a question being asked, what does Ellen think about X? We'll match the entity level to the word Ellen, which means now the agent is going to retrieve all the memories about Ellen. However, when there's another question being asked, which is, what's my opinion on remote work? This is conceptual, right? So this is a different granularities. It's actually going to do concept level semantic matching. So yeah, in summary, this is what we did in this algorithm update. Of course, as I mentioned, there are still multiple change that we do. Now agent generated are first class. There's also keyword normalization. You can read more about this in our updates. And again, the GitHub is open source. But I think before I end this, I would like to show you our benchmark result. So in Mem0, this is the current benchmark result update. As you see on long memfl, and Locomo is leading. But again, it's a lot of companies who have done this. It's also, I think, on this range, 93.4, 91.6. We are leading on the memory benchmark. And then for the BIM, we just run the tests. For the 1 million contacts, we achieved 64%. And then the BIM 10 million, it's 48.6. When it comes to benchmark result, what do we actually care? I mentioned before it was accuracy. Second is the cost, context tokens per query, and then lastly, the performance. For context token, we're able to retrieve this per query in average by 6,800 tokens per query, which is way, way lower than like the full context baseline. In industry standard, now we see 25,000, 16,000. You can see what's this number in the current like BIM or like BIM 10 million. But we are able to reduce it to 3 to 4 X query, fewer query, while still being able to maintain this performance in the algorithm, which is very essential. And this is what also the single pass at only extraction does, because we only pass it once, but again, there's a multiple layer how we score this retrieval, which allows us, even with such a lower tokens, we'll be able to still get good performance. We're not the best on the BIM or BIM 10 million, but on overall algorithm, we're top 3, because I think when it comes to memory benchmark, of course, you can always boost accuracy, right? But it comes at what cost? Whether it's the latency or the average tokens that we do. This is the breakdown for the scores. And again, this is one of the examples that I mentioned before. The temporal reasoning, information extraction, knowledge update, and the BIM memory benchmark is actually being tested on 1 million and 10 million tokens scales. So it's one of a good challenge if everyone's want to build on this. Our algorithm is also open source. I literally just pushed my PR last night, so everyone here can also work on this. What's next in our plan is how we are able to get richer temporal presentations, and also better modeling of cross-session event structure, and tighter integration with agent workflows. I can show what in Mem0 what it looks like. Currently, I also have my what it looks like if you're using Mem0. Let me see, continue with Google. Okay, so, oops. So this is what it looks like in the dashboard. I have my entities, Ellen, Chrome extension user, I have Livia Ellen. So you can actually have a multi-agent system because we have like different entities. And then here you have memories tied to that specific entities. Yeah, I use this a lot, and as you can see, it's actually stored here. And if I go to my cloud, let me see. Oh, it's showing right here. I'm working as a growth engineer, so a lot of my facts here are related to, you know, like what growth stuff. So I could specify, hey, list all my memories from Mem0, from this user ID, because I have different user ID. You can have multiple user ID, agent ID, or even to the level of run ID. That way you can run a multi-agent system. I'm able to see it here. And then lastly, in my Telegram, I love using OpenClaw. And we also have Mem0 in OpenClaw. I was in Japan last week to present a paper. And I use Mem0, I use OpenClaw a lot to ask questions. I also connect Mem0, so I can type here, list all my memories. It will run. I'm so excited when we do live demo. And it will be able to retrieve memory from Mem0. The setup is actually quite quick. You just need to copy. I think it's typing now. I hope we have a good internet. Let me see. While I'm running this, Mem0.ai. You can set this up by just copying this. And it will automatically send message to your OpenClaw, and then will give you, you don't need to even go to the website. You will, if I go to here, resource, blog, OpenClaw, right here. There we go. You can just type setup for Mem0, what's your email address? I type my email address. You just copy paste the token, and then automatically Mem0 is set up in OpenCloud. So it's that easy. We're trying to do an agent-first collaboration. And then over here, you'll see how the memory is being stored. And I can just type to OpenClaw, list all my memory, and I'll be able to have like the memory listed here across different sessions. Yeah. So yeah, that's about Mem0. And we also currently have this website that we run. Again, we love our open source community. It's called memorypapers.org. We write a visual explanation about how memory works. You can also request what paper we would like to write about. There's 54 papers. This week there's ICLR 2026. So we're definitely gonna have more memory paper published here. Great. If you have any questions, feel free to ask us. Thank you.
Great. Thank you very much.